Alright, here we go. 2.2. 7, 8, 9. Pretty fast problems. Um, I think if you know it. Shape of the distribution shown best classified as skewed left, true, right, true or false. The skew is the direction of the tail, so this is actually skewed right. The shape of the distribution is classified as uniform. No, this is classified as symmetric. It's unimodal. Okay, unimodal means one mode, one peak. Sometimes we call it bell-shaped. And as we're going to learn this week, sometimes we even talk about it as being normal. Okay, uniform would be straight across. A uniform distribution would be something that looks like this, where it's pretty close to flat across. Okay, number 9, I've got the question here, and I think I've got the rest of it. Yeah, the graph over here, so let's see if we can get them both. Rolling a dice experiment is conducted which 2 fair die were thrown 100 times. The sum of the pips. A pip apparently is the little marker on the side of the dice. Showing the dice is then recorded. The following frequency histogram was gives the results. Okay, so when you throw a dice 100 times, you will get a 2 exactly, that many times, 2 or 3 times. You'll get a 3 5 times, and so forth. So what is the most frequent outcome of the experiment? Most frequent is rolling an 8. Okay. The least frequent, rolling a 2, otherwise known as snake eyes. How many times did we observe a 7? 15. How many more 5s were observed than 4s? Well, there were probably 11 5s, and it looks like maybe 6 4s? 7 4s, we'll go with 7. So 11 minus 7 would be 4. What's the percentage of time a 7 was observed? Well, that would be 15. There were 15 7s out of 100 tosses altogether. So that would be 15 divided by 100. I was about to get my calculator out, go figure. 15% of the time. Describe the shape. The shape looks like we talked in the last earlier part, unimodal and symmetric. Can it be unimodal and not symmetric? Absolutely. This one is unimodal and it's not symmetric. Okay, so this is also there we go. Okay. Alright, so there's 7, 8, 9. Let's do 12. Okay, I should make this one bigger here so we can, read that a little easier. Oh. Okay, there's the graph right next to it. Sorry, should have this ready. Okay, so here's the graph. Forget about this. This is the graph here that goes with these questions. Okay, frequency histogram in the next column, the number of alcohol-related traffic fatalities by state, including DC in 2008. Determine the class width. So how wide is each class? So it looks like they are 200. Okay, so the class width is 200. So these are fatalities by state. And then this is the frequency. Okay, so let's think about what this is saying first before we just go blindly into this. So this is saying 26 states had between 0 and 200 fatalities. 14 states had between 200 and 400. And 1 state had between 1400 and 1600. Now, that's probably a more populous state, right? But that's a lot still. Identify the classes. So the classes would be 0 to 200. 200 to 400, 400 to 600, 600 to 800, and so on, right? To 1400 and 1400 to 1600. Okay, which class has the highest frequency? Highest frequency would be the class 0 to 200. Has the highest frequency. Frequency is just the number of occurrences. Describe the shape. Definitely skewed to the higher numbers. E. A reporter writes the following statement. According to the data, Texas had 1463 alcohol-related deaths, while Vermont had only 15. So the roads in Vermont are much safer. Explain what's wrong with the statement and how a fair comparison can be made between alcohol-related fatalities in Texas versus Vermont. Yeah, definitely that's wrong because, and I mentioned it earlier, there's a whole lot more people in Texas than there are in Vermont, right? So if there's a whole lot more people in Texas, you're going to expect more alcohol-related deaths. So how can I make a good comparison between the two? Are you thinking? Yeah, if you write it as a percentages, what's the percent? 1463 out of the Texas population. How does that compare to the, how many in Vermont? 15 out of the Vermont population. Let's compare the percents of fatalities in each of those and see. We might find that in Texas the percentage of fatalities might be, 1%, and in Vermont it might be 2%. I don't know, so that's how you would compare those evenly. All right, there you go.